So this question says that for a real number x, let square brackets x, which is known as greatest integer of x, less than or equal to x. Let f be a function which its domain is R and its range is also R, defined by fx is equal to 2x plus greatest integer of x plus sin x cos x, right? Then f is, so we have to see which property it is following, whether it is following both 1 1 and onto neither of them or either of them, right? Okay, so first we'll write the function as it is and we'll try to simplify it. Let's not get afraid of this long function. We'll break it down into three different functions: gx, hx, and mx. Now we'll focus on mx. So we can easily see that mx is sin x cos x, and we can see that sin 2x is 2 sin x cos x, and we can also apply the inverse property which will make it half of sin 2x. So whenever we see a big function, we see if we try to make it smaller, right? That it must be our first instinct. And this thing is bound between minus 1 by 2 and 2. So this thing must be in your mind. I've just written for your reference. Since sine 2x is from minus 1 to 1, if we'll apply half, then the domain of it is going to be from minus 1 to 1, right? It is bound. So now hx causes fx to be discontinuous at integer points. So what is hx? Hx is greatest integer of x, right? Which we broke down initially. This is hx. So now so what happens at integer input x in fx, right? So why we are saying it will be discontinuous because of hx? Why? So let's prove it right now. Okay. So fx jumps by plus 1 at each integer, right? Because of greatest integer of x. Note that gx and mx are continuous functions. Of course, mx is half of sine 2x and sine 2x is continuous, because of which mx is continuous, and gx is 2x, which is also continuous. So we are just trying to observe different properties of this function and just jot it down here, right? Okay. So now we are going to check the whole function for 1 1, right? So how to check? We'll try to see for a non-integer, right? So any non-integer between two consecutive integers. So the function is going to be 2x plus n plus half of sine 2x, right? So let's say the interval is n and n plus 1. For any number in between that, right, decimal, so greatest integer is going to shift towards this thing. It is going to round down the number, not round up. So then we'll have this 2x plus n plus half of sine 2x, and we'll try to find the derivative of this. So since n is constant, so the derivative it will become 0, and finally we'll get f dash x is 2 plus cos 2x. And we know that cos 2x is bound from minus 1 to 1. Its range is that. So the minimum value of fx is going to be 1. That is only possible when we substitute minus 1 in this place. So what interestingly we can find here, that since f dash x minimum is 1, that means it is always greater than 0, right? For any value of x we put, it is always going to be greater than 0. This means that fx is a strictly increasing function. Let's see if we can use this thing further. Therefore, in open interval, so open interval means that whatever number comes in between n and n plus 1, fx is strictly increasing and continuous. So remember, whatever discussion we're having right now, we are not including integers. We are just seeing whatever possibility is there between two integers, they are excluded. So now let's find the range, okay? So at x is equal to n, fn comes to be 3n plus half sine of 2n, right? And at x is equal to n plus 1, just less than n plus 1, right? Greatest integer of x is going to be n because we are going to round down it. Then f of n plus 1 negative is going to be this thing, right? All right. So now we'll try to find the difference of it, and we'll see that it is coming to be a constant 2, which is greater than 0, right? Since fx is continuously increasing between n and n plus 1, excluding n plus 1, why we have written this negative? Because we are including the value just less than n plus 1, but not n plus 1, because it is an integer without any jump. So fx is increasing without any jump between this interval. Therefore, it covers all values in between, right? It is not a problem for us. Okay. So now we'll do some different thing. We'll take two consecutive intervals, one between n minus 1 and n, and another between n and n plus 1, right? So we'll find the function, we'll substitute both these things in fx and see what are their ranges. So since we derived previously that fx is going to be increasing, so we can directly substitute the value of n and take it as range, right? Whenever we have an increasing function, all we need to do is directly put the domain or whatever intervals we are considering, and we'll directly get the range. So we are getting the range as these two terms in this case, and these two terms as in this case. So now it is interesting to note in this comparison that there are jumps of one and missed values between two intervals, right? So we can see that after fn, right, when we are seeing fn plus, so we can see there is a difference of plus 1. See this thing, and this thing. They are not same. Because of greatest integer, it is not, they are not same. But where are the values which are in between? Why is there a gap of 1? Why? That means that not all real numbers are in the range. It is not covering everything, right? And because of these gaps in the range, we are not getting everything. That means that fx is not onto. So why it is not onto? Because, for example, this is our domain x and this is our range y. So what we are deciphering from this thing, that not all values of y are being mapped, right? For all the x which we are inputting, we're not getting all values of y. Some values of the range are being skipped. So we are not having any mapping for this y2. That means it is not onto. It needs to be mapped, right? However, because fx is increasing and jumps never cause a repeated value, fx can be 1, 1. So what does 1, 1 say? 1, 1 say that all the values in domain must be mapped to a unique value, right? And we are getting a unique value. Every time we put some value of n, we get some unique value. Not n, somewhere between n and n plus 1 or n minus 1 to n. We are getting some unique range value. That means we can say that it is 1, 1, but we cannot ensure that all values in our range are mapped. That is why it is not onto. So it was so what we had to do is we must have very in-depth knowledge of 1, 1 and onto. Then we need to do some experiments on our function, try to simplify it, and finally we can say that it is 1, 1, but it is not onto. Option number A.